The company behind one of the most popular open source C2 frameworks just showed that an AI can build working malware from a one-line prompt to a tested, deployed implant in about 2 hours in 5 different coding languages. This is going to break the future of malware detection, and almost nobody is explaining what it actually means. By the way, if you're new here, my name is Blaze. I hack into systems for a living, and on this channel, I break down exactly how it works without the hype. And if you like this kind of teardown, please send the like button to Stage 0 payload that changes his background to a picture of Dennis Nedry and reminds him that he does not, in fact, say the magic word. Before we dive in, I had this video ready to record a few days ago and I held it because in the span of about 3 days, some new things turned up that turned a single story into something much bigger. And if I had shipped that one alone, it would have only left you with about a quarter of the picture. So buckle up. These 3 articles are all about to point to the same uncomfortable conclusion, which is endpoint security products that you're paying for are about to be in real trouble. 2 of these come from my buddy Adam Chester, aka the one, the only XPN. He's been a long-time, well-known security researcher and just all-around very cool hackermans. Adam set off with the idea of seeing how effective language models could be at creating Stage 0 implants. That's the initial bit of code that an attacker will send to their target to establish a foothold, and they're meant to be lightweight stagers to load the more full-featured implant. And the idea is to stop treating those implants like precious, artisanal, handcrafted, grass-fed, grass-finished, 100% organically raised pieces of code and treat them more like cloud servers. Treat them like cattle, not as pets. So you generate a throwaway implant per engagement, burn it, generate the next one. Who cares? They're easy to generate. The codes become cheap. That's the shift. The goal here was, could he one-shot a new agent from an initial prompt to deployment? No human in the loop. Just go from an initial spec to get a tested, ready-to-go agent for use in an assessment. Spoiler alert, no. At least not at first, but I do applaud him for the raw dog attempt and his exploration of what comes next. So quick context, Mythic was created by another buddy of mine named Cody Thomas, aka It's a Feature. It's never a bug, it's a feature. And it's a SpectreOps-supported open source C2 framework. Its whole design decouples the agent development from the C2, so rather than working around hiding a dedicated implant with like Cobalt Strike, you're 100% in control of that implant. Red teams already build a lot of their own agents to plug into it, and that's exactly why it makes it an obvious starting point. So like any good hitchhiker, don't panic when you see this diagram. Basically just showing us the main features of Mythic. It's an RPC messaging pub sub queue, and that allows for the various services to communicate. The components don't have to be in Docker containers, but they often do for portability. And the service's author is responsible for everything going on in that container. So when I'm doing Mythic dev work, I'll actually expose that Rabbit service outside the Docker network and connect to it remotely. But that's really just for dev work. You don't want to do that and just YOLO it in a live assessment. Now, Adam admits there's no scientific rigor in this post, and I admire that upfront honesty and how he's corrected for that with his future experiments by adding OpenTelemetry into his stack. But he takes the idea to just full send it and see what happens to avoid over-engineering or getting stuck in analysis paralysis. And sometimes that honestly is the best approach. Fire it, see what happens. I get stuck thinking I'm going to masterfully craft this project, and then the good intentions fairy comes right along and turns my mental masterpiece into hot garbage. So he starts with this single naive prompt here. Hey, go build me a Mythic agent with Stage 0 access. Gives it all the requirements and says, do it without any of my intervention. And he started this in February, so he was using Opus 4.6. And the main thing here that a lot of videos I see about AI coding development is they just skip to the end product where it works. No, what I like about this is he shows that he's encountered a problem and he's gonna have to engineer around it. The agent that comes up looks legit. He fully admits it looked perfect. The code was clean. The layout was cleaner than I would have designed. And of course the agent didn't work. It wasn't even close.
Kill me.
We've seen that a lot doing any kind of AI coding development. It had missing packages of the Docker container, incorrect path references inside its own Docker container that it created, and tried to invoke Mythic RPC methods that had just been completely hallucinated and didn't even understand the Mythic key exchange process. So the fix, when all else fails, try Markdown. So he goes and grabs all the Mythic documentation and builds it basically into a library. He sets all the documentation up as skills, and it stops making things up. So this gave it much better results, but it was still kind of just theory crafting. The second step he does is he creates a mock Mythic server. It's something he told me he's done quite a bit whenever he's reverse engineering something, and he just needs something to be just good enough to make sure everything's working. But with that mock server, he can actually test, hey, does callback successfully validate? He can smoke test them for the initial crypto key negotiations and check the tasking support. The next thing he does is he bumps it up a little bit. sets up an actual Windows 11 workstation for the Mythic agent to go test against. And he sets up a real Mythic server for it to go look and execute on the system and test every single command. He also adds into this a improved feedback loop with debugging harness and another Mythic harness, so he can actually see what's happening inside of the program while it's being executed. So he's getting full integration testing going. But then he adds a third tier to this, which is he adds a custom QA sub-agent. This one will start with a clean memory, retest it, and check if everything passes and fails. All the AI features work. So it's basically the AI grading the AI. Now, one of the things I really also appreciate that Adam did is he came in and provided all the prompts that he's using. I mean, not some of the underlying details for it, but the harness configuration is not that difficult and it's really easy to go reproduce. The result of everything actually improved quite a bit. There are still bugs in it. He was averaging about 2 hours due to repeated checks and QA failures, but he was definitely getting additional quality out of this. But then in comes OpenAI, and they had granted SpectreOps access to their trusted access for cyber system. That allows you access to additional models from OpenAI. They're cyber models. They're the same models that you would use, GPT 5.4, 5.5, whatever, but they have the guardrails detuned, so you're able to do more. Think of it as the anti-Fable, right? Fable, you couldn't do anything. In this one, you can do a lot more. So by porting everything he was doing over from Claude Code to Codex, he's now able to actually start making really big headway. And it was kind of funny because Codex was being super helpful and actually created a little icon for one of these test stage 0 agents he was making. He has no idea where it came from. That was actually one of the reasons why he decided to start adding the telemetry to it. But it was cool. Once he got that kind of sorted out and bumped it up to GPT's 5.5 cyber model, which released during part of this, it was working smooth. So using that custom harness that he created called Oracle, he actually had it spit out 5 different stage 0s. Each took about 1.5 hours to 2 hours to build, but it was in 5 different coding languages. He's got one in Python, he's got Go, he's got Zig, he's got some C#, a little bit of Rustation action happening here. It's proving the point, but keep in mind, these are very basic stage 0s. There's no evasion yet. So to understand this next part, let me give you a little bit of a history lesson. For like 20 years, static signatures and then later YARA rules, which focus on implant detection, are becoming vastly outdated, more so than they already have been. They've already been having a rough time with more advanced malware, but if every implant is unique, hashes and signature detection are basically chasing ghosts. AV vendors said, okay, fine, we'll stop chasing the ghost and we'll start watching the behavior. Okay, cool. The real bad guys are also able to use this technology to achieve these objectives. So behavioral detection has been the primary detection, but here's where they're kind of taking a flamethrower to the lifeboat. Because about 5 days later, Adam published part 2, where he takes apart the EDR itself. Part 1, Adam's building a better burglar, but now part 2 is the AI sitting down with the alarm system and reading every wire that's happening in here. And every red team worth their salt has private EDR bypassing tricks that get passed around in hushed tones at conferences. But as Adam points out, those are about to become very public conversations. And it's not just him. Justin Elzy over at TrustedSec posted very similar research to this, doing internal language model teardowns of EDR products. So you've got 2 really respected shops with similar findings less than 2 months apart. So what exactly are they seeing? In his own words here, he says, the big 5 are crumbling. So for months, they've watched the big 5 EDRs they've met on engagements fall to language model reverse engineering, specifically the on-host detections. And the kicker was the harness to do this was surprisingly simple. He mentions it here in the article. They've now got the exact rules, signatures, and models for every major EDR vendor sitting on an internal server. And Adam is deliberately responsible about this. He picks one example in this article, Cortex XDR, which is Palo Alto's tool, as an example, and he releases none of the decryption keys and no rules are being dumped. So in other words, this isn't criticism of one particular vendor. It's basically, here's a reality check and we had to pick somebody and Cortex rolled the nat 1 on initiative. So still making use of those OpenAI cyber models, he creates a harness called Dayshift. And Dayshift is basically just a Ralph loop running on a harness that's hooked up to things like Binary Ninja or Ghidra, grinding away on a dedicated host 24/7. And the lesson echoes part of that first post there. The AI really didn't need to be a genius. You just had to give it the right tools and let it run in a loop overnight. That's it. So what does it actually pull out of that EDR? Well, 4 things in orders of increasing oof factor. The first thing Dayshift pulled out was the DLL hooks in here. So the language model looked at the Cortex user mode hooking DLLs, extracted where they installed the inline hooks, and that's the thing you're basically watching you from inside your own process. You can think of it as a code execution man in the middle, where it diverts the code execution to itself, checks what's happening before passing it on to the ultimately real code or killing it if it thinks it's malicious. The next thing it pulled out here was the YARA rules. So Cortex ships with static YARA rules on the endpoint. The model found them, they were stored locally, they were encrypted with AES-128 and fully recoverable offline. And the secret signatures really weren't all that secret. So even adding a static string to something like this executable he shows here, of the GitHub address to Mythic agents, adding it to it triggered a detection. So there are static string matches in here. These are kind of riddle detections, but I guess it was popular enough they felt the need to add it in. The third thing that this language model went and pulled out was the behavioral detections. The lifeboat was getting mogged right now. The model reconstructed the behavioral detection layer. It came up with over 9,000 of these rules, including about 4,200 of the deeper behavioral rules, the behavioral indicators of compromise, from the plaintext metadata on the host. And Adam shows an example here of spawning a command.exe with some funky looking execution pattern that matched one of those behavior rules. So he's trusting what the language model is telling him, but also verifying every step of the way. You don't want to blindly trust but verify. The last thing I was able to pull out of this that I find the most interesting was the part that everyone assumes is that kind of insurmountable black box, and that's the machine learning model. This isn't a language model, this is a traditional machine learning model. And in this case, Cortex was using something called a tree ensemble score, and it was set to run over a list of engineered features that they're extracting. And so it recovered all the feature counts and the exact detection thresholds. Once you know those thresholds, you know precisely how quiet you have to be before they fire. And he even shows an example here where dumping the SAM hive gets blocked by Cortex. That's good, that's standard, we want this. But for some reason, there's a gap where dumping it to the RCOC directory is allowed. So it's one of those kind of detections that you can pull out of this behavior. Now stack those four together. The hooks, the signatures, the behavior, the machine learning layer of the modern endpoint defense, it can be read all off disk locally by an agent running in a loop.
I'm in danger!
Then he shows the move that ties the whole thing together, which is creating a simulated evasion bridge. Instead of testing each payload against a real EDR and risking burning them, he has the language model emulate the EDR. He creates two sub-agents, one just straight called emulate Windows, and another one called emulate EDR, to play the detection engine role, and a mock C2 that he's got called the upside down, which I find absolutely hilarious. What he's doing here is he's basically creating a fake Cortex, but it's running with the rules in the model. And it tells you if your payload would get caught without the real product ever seeing it. And hold on to that idea because we're going to revisit it in just a second. Because Adam built a very clever mock-up that's simpler and more effective than anything I would have come up with. But now I'm going to show you what it looks like when somebody actually fully packages this together and puts it in a kit that's ready to go and turned up to 11. Now, rather than emulating the EDR's behavior with a couple of sub-agents running in a harness, a researcher named Otter spent 6 months building the industrialized version of it. It's called Hevner, a modular EDR emulation engine for Windows. He reverse engineered 4 real commercial products. In here, he's got Sentinel-1, Cortex, CrowdStrike, Sophos, and he pulled all their actual detection logic and machine learning models out in the compiled YARA rules for the behavioral scripts. Basically, you feed it your payload's behavior through either a kernel driver or a telemetry pipeline. It runs through and extracts all that vendor knowledge, and then it hands you the exact verdict that the production EDR would give you without the live agent ever running. So you test your kit against Cobalt Strike, and Cobalt Strike never sees it. One thing though, Hevner is Otter's own internal build. He's not open sourced it. He wrote up in detail exactly how he does it here, and I'll leave the link to it down in the description, but he's not releasing the tool, and he's not releasing the extracted vendor logic. There's no public repo for this. So this is a look what's now possible, not a go download this now. Otter even gives the full architecture for everything. He's got 6 major layers here, kernel drivers, ETW event consumers, everything pipes down into this pipeline, finally into a nice little web console where you got it. And he goes into very deep detail here, so I highly suggest if this is your bread and butter, go give it a full read. He talks about AMSI script scanning, LDAP search filter strings, DNS resolution events. He goes pretty deep on it. Now, Otter also does mention there are obviously some limitations to this. What you're seeing is everything just extracted from the local binaries on disk. Every EDR vendor ships significant portions of their detection logic to the cloud. So doing reputation lookups, cloud-based machine learning models, which you're never going to get access to, threat intelligence correlations, all that stuff, that is still the black box. This is just what's running local to your machine. So let's put these three things together. You've got Adam over at Spectre Ops, responsible, just named one vendor, didn't release anything, just kind of explained the exploration process. Justin over at TrustedSec did the same thing. Otter detailing how he created Hefner here, and he's another, I think, very popular red teamer. He's actually mostly known for his CTF work, but as far as I can tell, he is a full-time red teamer. Incredibly smart guy. He's got a Git book over here of like just in detailing everything he does. Windows kernel exploitation, reverse engineering. So these are very smart, very responsible guys. So they're not handing you keys and telling you, hey, go forth and just hack every EDR possible. Reverse engineering commercial products lives in a really legally gray area. So zoom out with me, because all these things drive one big point home. Taken in isolation, yeah, they're kind of interesting, but the three of them together in such very close proximity are pointing to something really big. So let's recap real quick. AI now writes unique implants in a couple of hours. It now reads every layer of defense, and there's now even engines to emulate those so that attackers can test their stuff offline. Signatures were already pretty much dying, but behavioral and machine learning detections are about to start getting bodied. So the honest balance here, this does not mean to throw your EDR in the trash. No, it's still a needed layer, and the cloud side detection of these teardowns doesn't fully cover, it's still standing. Don't become some doomer. Defense in depth is still your best approach, but I agree with the predictions here that Adam made, that a wave of endpoint security rule dumps, evasions integrated into offset tooling, and it's going to be a bit of a pain for the defenders. And when the guys who break EDRs for a living are telling you the EDRs are in trouble, that's not hype, that's a forecast. That's why I held this video for a little bit, because one post is a data point, but 3 posts in a week, that's a warning. The EDRs are in big trouble. There's already teams they're working on the next big thing because they can one-up each other. They're going to love to. So don't get black-pilled on EDRs. No, they're still an important part, but it's going to have to evolve just like everything else is having to right now. But that's all I got for you guys. I'll catch you on the flip side. I love you. Peace.